Hi everyone. We're going to get started on chapter 3, physiology and histology of the skin. And where we're going is in 3-3. In this section, we're going to distinguish the 6 primary functions of the skin. So your skin is similar to, it's very multifunctional. Okay, and it acts as a shield for the body. It is waterproof. It's an insulator that protects our body against extreme heat, cold, and the damaging UV rays. Your skin's also a barrier that protects against harmful chemicals and bacteria, and it prevents infection. Our skin plays a really important role in bone health by maintaining or producing vitamin D. It mixes in with the cholesterol that is housed in the skin through the cell membranes, and it creates vitamin D. It's a big process of doing that. I was going to show you. I have a little thing here. So as the sun comes in, it mixes in with the cholesterol, and then it goes through the liver and then the kidneys, creating the active form of vitamin D, just so you know. In addition, our skin is a huge sensory storehouse, and it keeps our brain in touch with the world around us. The skin does all of this while being flexible enough for our body to engage in motion while maintaining a healthy exterior to allow us to look good and feel comfortable. Now, for these reasons, the 6 primary functions of the skin are sensation, protection, heat regulation, excretion, secretion, and absorption. And we're going to talk about each of these in detail, but I just want to show you, I have a little acronym right here called SHEEPS. SHEEPS is what I use to remember those 6 functions. Hopefully that'll help you. I know it's kind of weird, but it works for me. All right, sensation. One of the first senses to develop is touch. So nerve fibers in our skin, they do sense when we're touched. Now, depending on the type of stimulation, sensations felt on our skin cause us to feel, react, or move. Now, there's different nerve sensors, and they help us detect different sensations and perceive changes in our environment like heat, cold, touch, pain, pressure. You have these nerve sensors, and they send messages up to your brain, and then through the sensory receptors, and then the motor neurons, they send the message back to relay the message to your body how to respond. Okay, so I'm going to show you some of those. For instance, here in this picture, you can see one of them, the Ruffini's corpuscles. They detect touch, pressure, and heat. Here's a Pacinian corpuscle, and they detect pressure and weight. And then here you can see a free nerve ending. The free nerve endings, they detect pain and temperature. And then, let's see, Merkel cells, that's another sensory one that detects touch. And then right up here is the Meissner's corpuscles, and the Meissner's corpuscles detect sensitive touch, really light touch. Not shown in that one is, in this one shows you the hair follicle receptor. So when like a little gnat lands on your skin and he's moving the hairs as he crawls through there, you feel that through the hair follicle receptor. So it senses touch. Okay, again, Pacinian corpuscle, Ruffini's, and then again there's the Meissner's. Meissner's and the Merkel cells, and then the free nerve endings. Okay, another one that wasn't shown on either of those is the Krauss M bulbs. Krauss M bulbs, they detect cold. Okay, so those are the receptors in your skin, and they each have their own unique role. So these nerve sensors, like I said, that sensation sends a message. So like say you touch a hot stove or hot candle, hot curling iron, whatever. Okay, so when you do, it sends a message up the sensory receptors and it goes up to the spinal column. And then there's an interneuron receptor and it sends the message back down the motor neuron to the muscle, and then you move your hand. Okay, so that's how that works. Again, I'm going to show you another picture of that. So again, here's the sensory neuron. Those are the afferent, and then there's the interneuron, and then it goes down the efferent, which is the motor nerve, to the muscle. Okay, you do move your hand. It's called the reflex arc. That is the reflex arc loop. But then it also sends a message up to your brain. And your brain, it remembers, oh yeah, the stove was hot or whatever, or cold or whatever. It just sends that message to the brain. Okay, so also messages sent, massage, when we're massaging, that sends messages to our brain through nerve stimulation, and it lowers the stress in our body as well as promotes circulation. Studies, they've shown that stress reduction in babies and older adults when they experience touch or interaction with others does lower stress in the body. There's a whole wing dedicated to touch at the hospital in Miami, Florida, where they treat patients with massage and that because they know the power of touch and the stimulation of those nerve receptors. I remember when my youngest baby was born, he went through a lot of trauma through the birth and he was under a lot of stress, so he was in intensive care for a week. When I brought him home, the hospital sent a massage therapist to my house to train me infant massage to help lower the stress that he was under due to all the trauma from being born. So sensory nerve fibers, they're most abundant in our fingertips, but you also have a lot of them in your lips and other parts of the body. Okay, so we're going to go into, you guys can see that little chart there with all those in your book. Okay, now we're going to talk about protection. Your skin is a thin, strong protective barrier to the outside elements and microorganisms. It does have a lot of defense mechanisms to protect our body from injury and invasion. Sebum, oil on the epidermis, that gives us protection from external factors like invasion by certain bacteria. Now the acid mantle, that is a protective barrier, and it's made up of sebum and sweat, lipids and water. And I'm going to show you that. Here we have the acid mantle, and it's made up of two S words, sebum and sweat. And sebum is made up of lipids, and sweat is made up of water. Okay? Now your acid mantle, that forms what we call a hydrolipidic film, and it protects our skin from drying out and exposure to external factors that could damage it. Hydro, we know, means water. Lipidic means lipids. So the hydrolipidic film, that provides the oil-water balance on our skin surface. Now the average acid mantle pH is 5.5. Some people can be as low as 4.5 and some as high as 6.2. But the balanced pH, that is really important to protect our body from pathogens and to regulate enzymatic functions. Now our acid mantle is part of our skin's natural barrier function. Your barrier function is your skin's mechanism that protects us from irritation and intercellular transepidermal water loss. And that is caused by evaporation on the skin surface. So lipids, those are those substances that contribute to the barrier function of our epidermis. And lipids are those protective oils, and they are part of our intercellular matrix. That's that fluid between our epidermal cells. So when you damage this barrier layer, It causes a lot of skin problems, including sensitivities, aging, and dehydration. There is a little picture in your book on normal skin and damaged skin. I just happen to have this one that I use. So this one is normal skin, protecting us from pathogens, bacteria, viruses, whatever. And so this is normal skin, and this is skin that is damaged. So we can see transepidermal water loss from here, loss of moisture. And then also pathogens can enter into the skin and allergens and so forth. And then it does cause inflammation in the skin. Okay, so everybody has the same number of melanocytes. Those are the cells that produce skin color. A lot of people's cells, some people's cells produce more melanin than others. And your eye color is also the job of the melanocyte. So I want to show you how this works. First off, I'll show you what a melanocyte looks like. Here's a melanocyte cell. And you can see it has a nucleus, it has the rough endoplasmic reticulum and the Golgi apparatus. So this is the cell that produces pigment, and it protects our body from the UV rays. Now, melanocytes, they produce these little round spheres called melanosomes. And the melanosomes, they produce a protein called melanin. And melanin, what it does is it travels up, or melanosomes travel up these long arms called dendrites. Okay, and they go through a process. I'm going to show you here. So the melanosomes come up and they go through a process called exocytosis and endocytosis into a keratinocyte, one of your skin cells. Okay, so somebody like me, my skin color, Fitzpatrick 2, I produce about 20, I have about approximately 20 melanosomes per keratinocyte. But somebody of a Fitzpatrick 6, they're going to have up to 200 melanosomes per keratinocyte. Okay, so anyway, the melanocytes, they live in the stratum germinativum. I'm going to show you this. So here is the stratum germinativum where the melanocytes live, right here, this dark line. It's just one cell layer thick. They're columnar cells. And so what happens is those little melanosomes, when they go into the keratinocyte, they form like a little umbrella, and they protect the DNA of that keratinocyte from any, mutations that can cause cancers. So, but occasionally, the melanocyte, let me show you here, occasionally this melanocyte can have a mutation in its DNA, and then that leads to a form of cancer called melanoma. And then the other cells in the basal layer right here, or the stratum germinativum, these are basal cells, and that's where basal cell carcinoma comes from. Then the other cancer is squamous cell carcinoma. Okay, now your skin's most amazing feature is its ability to self-heal. Your skin can repair itself when it's injured, and it protects our body from infection and damage from injury. I don't know, I lost my train of thought there. Through a hyperproduction of cells and blood clotting, injured skin can restore itself to the normal thickness. Now we have these hormones in the skin called epidermal growth factor, and they stimulate your skin cells to reproduce and heal. So there's proteins and peptides, and they trigger the fibroblast cells. Here's a fibroblast cells, and they rejuvenate. Fibroblast cells are cell stimulators. I circled a couple of them there. They live in the dermis, and they produce collagen and elastin. Okay, a lot of skincare companies, they will use epidermal growth factor in their line because of it helps to reproduce and heal the skin. they reproduce the cells and heal. So like the skincare line I use, it does use epidermal growth factor in there. Anyway, so other protective components of our skin is our immune cells. And we'll talk about those later in other chapters. Okay, so heat regulation. Your body's average internal temperature we know is 98.6 or 37 degrees Celsius. When it's really cold outside or hot, your skin will automatically adjust to warm or cool your body as necessary. Now, our body maintains thermal regulation through evaporation, perspiration, radiation, and insulation. And you should remember those. Okay, so millions of sweat glands, they release heat from our body through perspiration to keep us from overheating. So then when we cool ourselves through evaporation on the skin surface, the heat travels up through the sudoriferous gland and out of the body. So blood flow in the blood vessels, they dilate also by assisting in cooling the body. Okay, so we're going to talk, I'm going to skip this little section here. When we protect ourselves from the cold, what happens is the blood vasoconstricts, decreasing blood flow. And additionally, you have a layer of fat that helps to insulate and warm the body. One thing I want to point out is when your blood vasoconstricts, it does that to keep the blood flowing to the internal organs that are detrimental. If they die, you don't get to live, right? So it's very important that we keep that blood going to those internal organs. So what happens is the capillaries have a little mechanism where it will shunt the blood across rather than going through those capillary loops. And that will cause sometimes if you're out in the cold a long time, it'll cause ischemia and necrosis. And that's what we know as frostbite, because the blood flow has been shunted to try to protect those internal organs. Hair follicles, that's another way that we regulate our body temperature and protect us from heat loss. So when you guys are cold, what happens is we get this little muscle right here, the erector pili muscle, which is attached to a hair follicle. It causes goosebumps. And then this reaction is thought to warm up our skin by little air pockets that are created under the hairs that stand up when the muscle contracts. Shivering, that's also an automatic response to the cold. It's just another way to warm up the body. So what I was going to talk to you guys about that I skipped is the term pore and follicle. Pores are actually tube-like openings for sweat glands on the epidermis. Follicles, those are tube-like depressions with oil glands attached to them. Now, a lot of follicles have hair and other ones are hairless. So clients, when they're talking to you and they're talking about pores, they're really talking about follicles. They just don't know, the difference of those. Now, sudoriferous glands, those are the sweat glands. I'm going to show you here. So here you can see a sudoriferous gland right there. There's two types, and we'll discuss those later. But sudoriferous glands, sweat glands, they excrete perspiration. And a lot of people, they believe that sweat detoxifies your body, but actually it's only 1% detoxification through perspiration. Really where your body does that is through the liver and the kidneys. Your sudoriferous glands, what they serve to do is they prevent your body from overheating. Okay, so heavy sweating can cause a loss of fluids, dehydration, and a loss of mineral balance that we need to keep our body functioning. So like, sports drinks like Gatorade and that's really important to replenish those minerals. Sweat, just like sebum, is part of our acid mantle. And the functions of these glands, we will discuss those more in detail later in the chapter. So now we're going to talk about secretion. Sebum, that's the oily substance, and it protects the surface of our skin, and it lubricates the skin and the hair. So let me show you those. So here is your sebaceous glands attached to a hair follicle. They're also called oil glands, and they protect us. The sebum protects our skin and keeps it soft, and it protects us from outside elements. Your sweat and your sebum actually have microbial properties. Now your skin, it's approximately 50 to 70% water. Sebum coating the surface of our skin slows down the evaporation of water, known as transepidermal water loss, and it also maintains appropriate water levels in our cells. Emotional stress and hormone imbalances, they can stimulate the oil glands to increase the flow of sebum, which can lead to acne breakouts. So that's another thing. Plus other things like hyperpigmentation as well, but we'll talk about that later. Absorption of chemicals, hormones, and moisture and oxygen, that's necessary for our skin's health. Now, vitamin D is synthesized and produced in the skin upon exposure to the sun. So I've got this little chart. So when the sun's rays come into the skin, they mix in with cholesterol, and that's a precursor for vitamin D, but then it's got to go through the liver and the kidneys before it becomes an active form of vitamin D. But it mixes with the cholesterol, and the cholesterol is in this cell membrane. It helps to maintain the form of the cell membrane. So the skin selectively absorbs topical products like serums and creams through the cells in the hair follicles and also your sebaceous glands. Now, while absorption is limited, some ingredients with a really small molecule size, they can penetrate the skin. So the smaller the molecule, the more penetration. Now, the penetration ability of the ingredient, again, like I said, is due to the molecule size and other characteristics of the product, like the polarity of it. Lipid-soluble products, they do penetrate better. Now, there's different routes of penetration through the follicle, through the follicular walls, I should say, also through the sebaceous glands and intercellular or transcellular. And I'm going to show you this. Small molecules also, they're permeable through the cell walls and they can penetrate in the cells. But larger molecules are non-permeable. But here's how they go through the skin. So this one is the intracellular. Notice they go right through the cells. This is the brick and mortar system. It was Dr. Peter Elias. He's a dermatologist from San Francisco, California, and he's the one who come up with the brick and mortar system. But anyway, so the bricks are considered the cells. So products can penetrate that way. They can also go through what we call transappendageal routes. So they'll go right through the appendages like your sebaceous gland or your sudoriferous gland. The other is the intercellular route, where they're going to go in between the skin cells. So that's the way that different things will penetrate. Now, absorption of select topical products, that's what keeps our skin moisturized, nourished, and protected. Scientific advances are continually resulting in the creation of new products that will readily absorb into the skin, and it makes them more effective. Like nanotechnology, that transforms skincare products. micronizing the particles so that they can penetrate further into our skin. I always think of this like the nitroglycerin patch for people who have heart disease, or the hormone patch. That's another way of bringing, those substances into the skin. A lot of skincare ingredients, they include prescription creams, and they penetrate deeper into the layers of our skin. And this can affect either harmful or beneficial depending on what it is. So I think of it like this, like retinol. If retinol is too strong, it can be harmful. But if it's in a delivery system where it just delivers ingredients at little microscopic times, then of course that's better. Remember this, the term intercellular, that means between the cells, and transcellular means across the cells or through them. Trans always means across. So that's the end of this theory section here. But I do want you to answer the questions, and you'll see them at the end of this. One of them is, what are the 6 main functions of the skin? So I need you to know those. Remember the term sheeps, okay? You do need to know those again. Like I said, they have been on the Idaho State Board exam. Another question is, what is the barrier function? Another one is, how does sebum protect the skin? And then, what is the function of the sudoriferous gland? Know that because that has been on state boards. And then, what routes does the skin have for absorption? What route does it take? So I want you to write those different routes that absorb. Now, another thing that you will have to do after this video is you will go into another one right below the read section, and it's watch. And it is called the skinny on the skin. So you need to watch that. And then there's a little do section, and that one is functions of the skin. It's just a little matching thing. And then there's another do one that's called functions of the skin. It's true and false questions. And then the other do section is choosing products case study. So you need to complete all those. Now those questions that I just told you, the check-in questions, you can either email them to me at krista@oliverfinley.com, or you can send them to me, the answers, on the app. But I do want you to do those. Okay, so that is it for this section. I'll see you in the next one.